Hi, this lecture will review a model we will use when analyzing electric drive systems as components in powertrains. We will also describe three main parameters that are used to specify the performance of an electric drive. We start by presenting the model we need to analyze the electric drive. The electric drive system is the electric machine and its power electronic inverter. For our purposes, a static model is sufficient, since the dynamics of the electric drive is much faster than the dynamics of the powertrain. The model needs to describe the interfaces between the electric drive and the rest of the powertrain only. That is, the shaft torque of the electric drive, the shaft speed, and the electric power. We assume the inverter is connected to a direct current source, in most cases a battery. The model describes the maximum operating range in terms of shaft speed and torque. It also specifies the combined efficiency of the electric machine and the power electronic inverter for each operating point. Note that the efficiency is defined in two different ways. In this way, when the electric machine operates in motor mode, that is, the torque is positive, or in this way in generator mode, when the torque is negative. Both definitions are needed since the power flow changes direction when switching between the modes. There are some terms we will use to describe the operating region of an electric drive system. The maximum speed. The base speed is the point where the torque starts to drop. Below the base speed, we say the electric machine operates in the constant torque region. Between the base speed and the maximum speed, we say that the machine operates in the field weakening region. Here the power is constant in the ideal case, however, in the real case, power often drops at high speed. The operating region we need for an electric drive system is specified via the requirements we put on the electric machine and the power electronic inverter. The main parameters are the maximum torque, and it influences the operating regions as shown here. Secondly, the maximum speed of the drive. And finally, the maximum power. These three parameters can be chosen rather independently of each other. The electric machine designer can also modify the design, for example, modify the efficiency or the torque characteristics in the field weakening region. For our purposes, we just assume that those details are given by the electric machine supplier, and we will not discuss how they are optimized. Now you know the model we need when analyzing the electric drive system in a powertrain, and the three parameters we use to define its operating region. Thank you for listening.